Our topic today will be about when no becomes yes. And you all know when that happens. And why it happens, you don't know exactly, but it happens. So it happened to us also. This is the test lab at Sabert, and you see all the equipment. So they got shakers there, they got all measurement equipment, so we can do a lot of testing there, and that's great for us, but we don't have that in a museum. So working together with a company like Sabert, that saves me a lot of hassle and organizing. You can do things together. When no becomes yes, shipping fragile paintings all over the world, and especially by air freight, that's the worst you can have. When I got a loan request in 2015 for Charlene. Charlene is one of our most important pieces in our collection. I was like telling the people, and the conservators were telling management, don't do it. You can maybe do it to Tate, we can put it in a truck and then we can control that, but the rest of the tour, cancel it, don't do it because it will be terrible for that painting. Of course, we were overruled, and then I was thinking, yeah, that's good. That's good that I've been overruled because, yeah, I can do something about it. How we traditionally packed our paintings, I knew that shock and especially vibration was be one of the main, how we call it, the painting is vulnerable for shock and vibration, but also for fluctuations in humidity in temperature. But shock and vibration, that is the topic that I was like learning about, and that it was important. And I have to take you back a little bit to 2010 when we started a test on the rental crates we could rent here in the Netherlands. There are a lot of them, there are all kinds of them, there are types, and they've got like all different materials in them, also to reduce shock and vibration. We did it with a bunch of museums here in the Netherlands. I got a group of 8 together. We did the research also with our cultural heritage agency in the Netherlands, and that was important because they got all the researchers that could help us. And we included the shipping firms because they got the rental crates, and you have to include them to do your research. We did risk analysis. We did it in a group, so the outcome of that was also surprising for us. Some risk we saw as an individual, was it a risk at all if we had it in the group, because nobody experienced that kind of risk before. So that was a good outcome. We tested users' friendliness, climate test, and then shock and vibration test. And that was new for me. I didn't know how to approach it. So when we were talking about it, where can we do shock and vibration tests, and what do we have to test about those shock and vibrations? Now, what we did is you got like a 4-step program for testing. So the 4-step, we started with the last. So that was the first thing that we did wrong, I think, in that test. And actually, you have to define step 1, so environment. Who knows the environment that we are experiencing? Who does a lot of data logging. I didn't do it before, so I didn't know what kind of vibrations and shocks we would experience in art transport. Where are the levels? Which levels do you experience? It was a new. So what do you have? Also, you got your product. The product we are using is our object, so that's also an easy one. You know your object, but do you know the natural frequency of a painting? I asked our conservators, what is the natural frequency of that painting from Shailene, what I had to move? Nobody could tell me, and nobody could measure it also. So that is, yeah, that's before I knew Kirsten, so that's why I'm taking a little bit back in history. But you could have a damage on your object during transportation. Then you got your object and your packaging. Now, we did it traditionally. We found that it was working for us, but we didn't know what we were doing exactly. So, bam, damage. You don't know because it's cumulative damage that you see, and you don't see it at once. So, but there will be damage in your painting when you don't use the right isolators during transport. So, what Michel was telling me is, why don't you do a life cycle analysis? I said, life cycle analysis, what is it, and what do we have to do? So he told me, oh, it's easy. What we can do, we put a crate on a dolly, we put a data logger on it and see what is this natural frequency, what is the frequencies we experience on a crate on a dolly. What is it if you got your crate on a J-bar and it drops a little bit? What is the shock? So I started to do some measurements and to get an idea what we had to work on. So this is what we were working on. So I think Michel is taking over now from me and explain a little bit how.
Oh, was het snel naar boven terug? Ja. Yeah, Mark was coming in our laboratory, I think in now nearby 2011 it was. And we talk about the life cycle analysis. And he was looking to it from, what were you talking about it? Then we say, no, you have an object, you transport it from A to B, what we see. Now you have some storage, some transport, some handling, and on the end, the user. You have some environmental factors. Temperature and UV is famous. Everybody knows something about it. But how about when you transport it, about shocks? I asked Mark, the environmental, which kind of trucks you use? Do you use mechanical handling? Do you use trains? Do you transport by boat? That's the first thing where we ask him, and he cannot give an answer on these questions. Then we look for him in the test standards, or in the literature. We take the Harrison Shock and Vibration Handbook. That's my most important handbook. But it was so difficult to read it and to put it in practical. Then we take some standards, not Dutch or German standards, but the English standards from ESTA of ASTM. That are in my world, the most famous transport standards worldwide. Or military, but military was a little bit too heavy for them. But we not found the right, the levels, but for the environmental. The next step, what we do, is start up to make some measurements. This is a measurement where we put a data logger, what you see in the red. We put it on the bottom. We put several accelerometers nearby the object, and we transport it from Amsterdam to New York, Los Angeles. And what's important is when you put a data logger in your system and you put it in your truck, is the location of the data logger. I like always to put it on the backside, but Mark like always to put it in the middle because the vibrations are doubled on the end. Just for measurements, it's the best to put it on the backside. But let me come back to the airplane. What you see here is a typical measurement of vibrations on the airport. And what you see is when it's on the airport, it's moving to the on the way on it, and you see shocks from 6G we are measured. When flying, you see not really vibrations, but on the right, you see what happens is the air pressure go down, and it go very rough. It's from 1,000 millibars to 800 millibars. But when it's landed, we have also not measured so big shocks of vibration. Only when they take it away from the airplane, come back to the storage, you measure it again, shocks. What nice is, we put also a GPS log on it, and on this way, we measured 6G's acceleration.
Okay. Yeah, well, I was thinking, yeah, 6Gs, that's a lot. But there on the right, we see that the cars made a right turn and then a left turn. But what did the guy do there? And what was happening? I don't know. But that's also what you can measure. You can measure where your cargo is, because this is the route you aren't allowed as a courier. So we could see what those guys on the airport do. So that was new for me.
But we are a lot of time concentrate what outside happens in the museum, but also what inside in the museum is very important, because when you look on the depot, you have a dolly, and we go to the truck loading station and do some measurements with 25 kilograms on it. And what our surprise was, is that you see on 26 hertz, you have a lot of amplitude. Also, when we do other measurements, from 2013 to 2019, it's in total, I think, 50 measurements now, what we make.
Yeah, I think so.
And what you see is, I make it a bullet, that more than 30%, 40%, of the transport is more than 5Gs. And after 5Gs, we say you can get some problems when you have not good protection in these measurements. What unluck is the vibrations in the tricks that you are using here. They are quite good. It's only one measurement from 12 March. It was a little bit high, but the rest, well, it was not so bad. But for shocks, the handling, that is a given problem. It was also with the Van Zatkin. It was a shock of 17 Gs. I asked Mark, how was the transport? He said, it was easy. It was only from Amsterdam to Den Haag. Nothing happens. And then I opened this valve. I was shocking. I said, what happened?
Yeah, and I didn't know by first. But when we were loading, the pallet that was under that crate was a little bit narrow. So the pallet jack was stuck a little bit. So I pushed it to get it in, and then it jumped. It was unstuck. So it jumped against the crate. So the input that you see is like one big shock. And that are the things that are happening in our field when you're thinking, oh, I got everything under control, and then it's that one thing that it isn't. So good preparation is important.
But we do also measurements for other customers, because we are a commercial test house. And this was one of the pallets where we are transported. And when you see in the second row, it's the Gs. And then you see 99 Gs with a time of very short, only 5 milliseconds, 6 milliseconds. But this transport, it comes from the Netherlands to America. And by when they are unloading the ships, they get a lot of problems, this customer. So you are lucky with the results what we found. But we go back to the internal transport in the museum. And what we have also measured was very nice, is to close the boxes with a special screwdriver. How do you call this?
Impact range.
And then what you see, It were shocks nearby 3 Gs every time in several seconds. Dus it's important when you closed your box that you use the right tool. We have also asked Tom to do a test. And we like to know which Gs you will measure it. But the shock was so heavy that my measurement system was clipped at 200 Gs. Thus, we cannot measure it, but we achieved it was nearby 250 and 350 Gs. When this happens in real time, I think you have a problem.
So, when it was in 2015 that I got that loan request, yeah, I knew what I had to do a little bit. I knew I had to ask for some help. The loan would go first to Tate Modern. I prepared and asked, wait, that's not a good one. So I knew that I had to do some more research. Research is important in our field. I knew I had the opportunity to get some funds because the loan was a high standard loan. It was to several museums. It was on a big tour. So I knew there was money behind the organizations for it. So I could do some more about my crate that I wanted to build. I also knew that I could make my next step in designing a crate that was different than I was used to and that was standard here at the Stedelijk Museum. I was ready because we did the research with the rental crates, so I knew a little bit of shock and vibration and where to go to and what I could do. And I was prepared. So I had Michel already there. I had knowledge. I have a good team that can build the crates. I knew that I had to seek outside help to make the calculations and which isolators I had to use. So I knew Trios Engineering. It's a big engineering firm here in the Netherlands that does only packing for industry, but they do fragile chip making machines, the packaging for them, and they ship them all over the world. So they're a really good, experienced firm. What they ask me is, what size is it that you're going to pack? What is the weight of it? That's important for them. Center of gravity, that's what they all wanted to know. Those three things are easy. We made an inner box, we gave them all the measurements, the weights, the center of gravity, but then they wanted to know what's the natural frequency of that painting that's inside and which frequency do we have to dampen. And I couldn't tell them. So they were also thinking, well, I have to get back to you because we also don't know what natural frequencies are in paintings or in the objects you are shipping. So I gave them the dimensions. It was a big painting. I gave them the weight, but the natural frequency that was still difficult to get. So what they decided to do is if the natural frequency isn't known, we're going to dampen your frequency from vibrations in a really early time. So when there are vibrations that came in during transport, they will be dampened in a real early moment. So we built our crate. Jan, our top carpenter here at the Stedelijk Museum, he was building that crate. He worked like 3 weeks in a row to build it. We got the wire ropes that Trios Engineering advised us to put in. We had to put them in a 45-degree angle on the inner box. So it's hanging there, and compression wire ropes that are under, they don't do much, but it is the ones that are on top that are the big ones that are doing all the work. So that was also new for me and for the museum. We decided to give it a go for the last two venues that would be there. The last two when we had to fly to the States, but first we had that loan to the Tate Gallery. I went to Michel to ask for him, can you loan me like a data logger that is real good and that we can see the measurements that were coming in, the vibrations that will come in from that transport, and see how it is dampened on the inner box. So Michel said, yeah, of course, and I will also make the readings for you and explain what that crate will, how it will react. So when it came back from Tate, all the data, Michel and I were looking at it and saying, "Oh, we can proceed with the rest of the tour because we see that the box is reacting really as was calculated." So then we went to Luxembourg and put that crate on the plane. Okay, so you could see what were all the steps. So this step 2, a lot of vibrations came in that crate, and the wire ropes really worked, and we were so glad that it worked. So I think you're now, Michel.
Yeah. Now, when we have measured the first step to see what the environmental is, then we look what is the products, what they are doing. I take some paint and put some pasta on it, and make some vibrations on our shaker. And what you see is at 10 Hertz. You see in the middle of the pasta, it's a little bit moving, but nothing happens, especially. We get more results, but the best what I like was on 77 Hertz. What happens? It gets more destroyed and destroyed and destroyed, and that's my life. I like this. But Mark not so much. But what happens? It gets looser and looser and looser, and the frequency is not 77 Hertz, but go down to 45 Hertz, and then on the end it will break down. It's important to know what's the product fragility. What we see here is also the transmissibility, where we talk about this morning. And the red line, what you see on the top, it's the damping factor. And everything above the top, it's in damaged area because it goes in resonance, and everything what below is on this top, it's in damping, and that's the best. In this situation, it's also for shock. We say above the 5 Gs, you get some problems with your arch. And when you measure it with the what you see before in the movie, you get a lot of shocks and vibration during the transport. And when you do not protect it, you get some problems when you not use the right cushioning material. What's important is to look which material you like to use. That's step number 3, what we say. You do some drop test with cushioning materials. On the top, on the right, it's some rubber elements. What is moving, what you see, what happens inside. And so you are a little bit prepared. And when you have a transport, this is what we measured on the airport. The input below, it's 7 Gs with a very small time of 9 milliseconds. But the response, it's above the mount of about the cushioning curve material. It's nearby 2 Gs, but a long time, because the energy you cannot lose, but you can move it to the time. And that's important for us. But we have also, very important, is to test the cushioning material, because there's a lot of rubbish in the market. One of the things is these yellow things. We test it in our laboratory. And what happens? You put 10 Gs in and you get 12 Gs back. Also with the blue line on the second is the vibration. From 10 Hertz to 100 Hertz, nothing happens. It gets worse at 90 Hertz. Dus this solution is for us not good. Also, when you use a dolly and you have a transport kit, of you do make the measurement what we saw before, we see 26 Hertz. This is a transport kit what we used in 2017 on our vibration shaker, and it's also nearby the 72 Hertz. Dus your amplitude gets worse and worse and worse because you make it double, and then you get some problems. And also with painting, what we saw, it's 77 Hertz. When you vibrate it, and it's exactly on the same frequency of your transport box inside, you get problems. Dus very important is, do not leave every brochure inside from this is the perfect isolator, but test it also. And that's what we are doing in our laboratory. What you see is a cabinet, of in a transport box, what we put on a shaker, and we carry out the vibration profile of a dolly with nylon wheels. And what we see is the white line is what happens when we measured inside the museum. The line on the top, the red line, what you see, this is what the transport box is doing. Dus it's a little bit weak. And the green line, it's the amplification of, is the isolation of using the cushioning curves what we used. And what you see is after 10 Hertz, there's no of the energy go really down. And with the line what you see is nearby a factor of 420 times isolation on these frequencies. What also important is when you drop a box, it must also work for shock. Dus not only for vibration, but also for shock. We make this test with dropping, with the box which is staying outside. And what we saw, it was a shock of 45 Gs. And what we get back is the orange line, what you see. And it's nearby 5 Gs. It's nearby 90% handling what you are, make a success with damping.
So, what I want to tell you and bring to you is that there's a lot of knowledge what you can get through data. So measuring your transport and putting the data in sheets that you can read what it is. So also see when those impacts are and how they are, how they occur is important for you. So querying and data logging together, that makes you to understand what how the transport is going and what your painting or sculpture is getting into. What I also learned is that you have to seek help from specialized companies. You can't do it by yourself. The vibration and shock and vibration knowledge that you need to do it good and precise, you need people that understand it. And I know in the field there's a lot of knowledge, but sometimes you have to go to a specialized company and reach out for them. Collaborate with other museums. That's what I did in the rental crate research. That's a good thing to do. You can spread cost, you can spread everything. New methods, materials, be on the lookout, join research programs with the university. You can join programs with industry. That's what I'm doing now with, I've got a material, aerosorber, that makes that I can use the aerosorber as a isolator that is smaller, so I can ship bigger paintings. So when I got that Charlene, that was the biggest I could ship, and everything above that, I couldn't do anything with it because the isolators needed space in your crate. So you need like a low profile isolator. So that's what I'm working with aerosolver to see if that works for us. We tested it, and that's the good thing to do, because you get materials and they say, oh, it works like that, and you have to weigh your weight, what's the weight of your crate, and so you can divide it, and you need so many cushioning material, but sometimes when you test, you see that you need more or less. So testing is important. Shake a little bit at that curve, and what you can see in the line that's under there, that it already is dampening just just right of 10 hertz, so around 11, 12. So that for us that's good, but because you want to dampen in those frequencies. So that material that I'm working now with, it's a pass for us. So I want to thank you and have fun with the next presentation.